All right, friends, welcome. It is our week 5. Can you believe we've already been here for 5 weeks? We've been doing this, which is wild to me. I don't know if it's flown by as fast as for you guys as it has me, but it has really, really flown by. There is quite a few things happening. We are looking at MySQL and really the SQL language as a whole this week. And then from there, we are continuing with different assignments. You have some core assignments. You have books, SQL, and Dojos and Ninjas. Those are your 2 core assignments. Don't forget, you do have a discussion question due this week. So please make sure that you guys are taking care of those and handling that as well. I'm going to move my desk up. Normally I stand when I teach, and I was like, oh, I'm going to sit. Now I'm going to stand. So sorry if my camera looks like it's different, but I'm going to go ahead and stand for that. Perfect. Great. Well, today what we're doing is we're going to be talking about the SQL language. We're gonna learn it. So technically, you guys are learning another language, if you will. It's kind of known as another language, and this is something that is going to be useful for you, especially in the job hunt. This is something that I would really encourage you guys. You're going to need to know how to do it anyway, just for this program, for us to query our database. But SQL code, knowing some SQL can be really beneficial for the job hunt, really beneficial for your career. I've got a great friend who is good with SQL and knows just a little bit of Python, and he makes well over $200,000. Not as a developer, but he does like sales and works with data and big databases. Not as a data scientist either, just more so uses a data tool, knows SQL code, knows how to query and get data for customers, creates that, sells it, and makes a whole bunch of money. So this is something that's really important. Most companies like Starbucks uses SQL. So knowing SQL, knowing how to use SQL, knowing really how to just be able to query data and join tables is going to be something that is really beneficial and something you're going to need to do. One thing I want to note is on our agenda here, we see that we have our CS assembly. We're not going to have that. We're just going to have a normal algorithm session. If there's anything you guys want to talk about this Thursday, we can. We might do like update and delete. I think we'll just do create and read today. Maybe do update and delete on Thursday, / do an algorithm if we have some extra time. We'll do something fun there. And then just looking into the future, we're jumping into Flask next week. So we're going to go back to our VS Code, and we're going to start using Flask. Now, Flask is our micro framework in Python. So it's really something that we have. Python is this big, awesome language. And then Flask just gives a little bit more of a framework. It's called a micro framework because it's really light, but it just gives a little bit more of a fundamentals. Helps us set up and say, cool, this is our mold. This is what we're doing, and how we're going to utilize the language. And so once we do that, we're going to be back in languages or back in Python using Flask, learning it, and then we will start in week 9, start doing both together, where we're going to have have a Flask server, and then we're going to be querying our database and retrieving information. The way we're going to query them is through these queries that we're learning today. So though it might seem like it's random, we're going to start using these in week 9. And so we'll need to make sure that we're kind of learning both. And then for the rest of the time, we'll be using these queries all the way up into the Belt exam in week 15. Cool. So I thought today would be good if we just hopped into really MySQL Workbench. We're going to forward engineer. We're going to create a table again. We're going to get more practice doing that. And then we'll actually make some queries. We'll insert some data. We'll grab some pieces of information. So if I wanted to create, let's say that I'm going to create a database for, let's say, a food truck. Yeah, let's do a food truck. Actually, let's do a movie. I like movies. Movies is simple. Movies is easy. I'm in my MySQL Workbench. Where can I go to create that, to create an ERD for that? What button would I press?
Local instance.
Not local instance. I'm going to click this one right
Oh.
here, right? I'm going to create a model. Now you could probably, Jeffrey, do your local instance to go that way, but I'm going to create a model this way, and this allows me to utilize and create this. Now, when I create model, when I just do that little plus sign, it brings this up. Now, this is my database or my schema, right? And so I want to name this. I'm going to name this Python movie, because I think I already have a movie DB in there from another class, Python movie DB. Great. And this is the name of my database specifically. Cool.
Excuse me, I just have a really quick question.
Mm-hmm.
Is a schema the same thing as a database?
Mm-hmm. Yeah,
Oh,
schema is just how you're setting it up. It's referred to as a schema. MySQL database is all of your schemas collectively. So you can have multiple DBs, but yeah, it's a schema. You can use those interchangeably. So we've got this Python, great question, Kevin. So we have this Python movie DB. And now let's go in and let's add a diagram. Let's actually add something that we can have some information for, or what we call a table, right? We're going to add our first table. So I'm going to do that. I'm going to create my first table, and let's create a movie table. So just notice I click on the button that kind of looks like a grid here, and that's what adds my table. And then when I double click it, I can do my table name. And remember, a table is just what we're using to represent our data. You can sort of think about it like a class, right? It's something that's a blueprint to represent this is how our data is going to be held. And so I'm going to call this movies. Cool. Now, each table has at least 3 things minimum that it's always going to have. Does anybody remember what they are?
ID,
Yeah.
created at,
Uh-huh.
and updated at.
Exactly. So we have an ID, a created at, and updated at. When I'm creating this ID, remember, it is my primary key, my unique identifier. Sort of think about this like your social security number. Or some sort of identification number, right? That says that is who you are. Primary key does the same thing. It's how we're going to be able to look up and retrieve a specific instance of information. This NN stands for not null. We're saying, hey, there cannot be an entry in my table, in my database that has this as null, meaning that they didn't pass anything in. We have to have this. This is a requirement in order for it to be able to be in my database. Now, we're going to learn about validations very towards the end, I think like 13 or 14. This is sort of like a validation, basically saying, hey, if there's not a value passed in, I don't want you to save that in my database. This is not what we're going to rely on. We're going to build our own validations, but it's also something sort of in the background as well. And then there's a third box I need to tick for my ID. Does anybody remember what it is?
Auto increment.
Mm-hmm. Yeah, auto increment. Great job, Jeffrey. Just AI, right? For auto increment. That is because we want to start at 1 and then just keep going up. Never backfills. It never, if we create a movie and then delete it, we don't want to go backfill that ID. We just want to leave it as is and keep adding a brand new ID. Cool. And then like Ashella said, we have a created at and an updated at. Anybody remember what data type created at and updated are?
Date and time.
Yeah, date time. And here. Now, we can do 2 things. We don't have to pass in anything here in this expression. Now, if we don't do that, every time we create a new instance, we're going to have to use something like within Python called datetime.now to kind of basically give a time frame, a timestamp. I'm a little bit lazy. And I think that this is so easy. What I can do is I can come here when I'm creating it, I can right click and I can just say default current timestamp. Now, when it's created at, we're saying, hey, whenever this is created, I want MySQL to grab the timestamp when it's being run and just put that value for my created at. I can do the same thing, but here I go to the very bottom, I right click and I say default current timestamp on update current timestamp. What that's saying is, hey, if there's not a value here, the first time it's being created, take that current timestamp. But also, when it gets updated on update, I want you to also get that timestamp And so that way we'll be able to keep track of every time it's updated. We'll have that new time so we can know when it was when it was last updated. Cool. Now there's some other columns we're going to need. We're going to have maybe we'll say a title. And title is going to be a varchar. Can anybody remember what a varchar is? And then what does this 45 mean?
It's how many characters.
Exactly. It's just like a string. You sort of think about it like our string. It's just variable characters. And so we can go all the way up to 255. I'm going to say 95. That's just, there's no rhyme or reason. And I'm also going to right click and move up. That way it is above. Usually created at and updated at are the last thing and ID is the first thing. Cool. So we have our title. Maybe we create a genre. Varchar 45. That sounds fine. We move up. We move up. Now, normally you can create it at and updated at just at the end, so you don't have to keep moving everything up. I just like to always remind, like, what are the 3 that we need? So that's why we're having to do that. And maybe we have a director. Cool. And we can give this maybe 100. 105. That makes sense. Maybe somebody's got a really long name. Move up. Move up. Cool. So we have this table called movies that's got an ID, a title, a genre, a director, created at, and an updated at. Perfect. We have the right data types. Our ID is always an int. Title, genre, and director. Those are just varchars. Great. So we're ready to forward engineer this. Well, let's go ahead and do this so we can add and insert all of that. What do I do if I want to forward engineer this? What can I do here?
Save it first.
I'm sorry?
Maybe save it first.
We could save it, yeah. So we can save model as, and then we could save it as an MWB file. That's a great idea. I'm not gonna do that right now, but that's a great idea. Always save them as an MWB. So that way, if you accidentally make an error, let's say you spell something incorrectly, or you want to change it, you can just open it up instead of having to do it again. So we'd save it. And then after, we just go to database and we click this forward engineer. Now, if you're on a Windows, you could just do Control G. It's going to bring up the same thing. We say next. We say next. Now I type in my password, and that is the password that whenever you created it, that's what it does. And we're just dealing with tables, so we don't really need anything else. Next. Again, here's my SQL code. Next. And as long as we get the 4 check marks, finish successfully, we are done. Great. So I can get out of that. I can come here I can get out of my model. Don't save. So now let's go back. I'm gonna go home. Oops. Oh, I clicked the wrong thing. Cool. So we go back home. Now, Jeffrey, we go to our instance. Let's go into our database. And we have all these schemas. We have all these schemas. Now, I was stuck on this yesterday for the longest time in another class, and I felt so silly. If you see this and you can't figure out where to go, you just go to this button right here called schemas, and it should show up. If your database is not here, even though you forward engineered it, click this button right here, and that will refresh your database or refresh your schemas. And so then it should show up. But we see our Python MovieDB, and we have our tables, and here we have movies. And if I click on this, you can see all of the different pieces of information that we have created. Cool. Now let's go to, I'm going to go to our dashboard real quick. And I want to look at kind of the MySQL section, because there's a lot of things that we can follow through, that we can look through to kind of help us as we're dealing with this. Go to this third section called our MySQL queries. We've already handled all this connecting. We've already forward engineered. And so now we're going to get into the actual SQL language, right? The actual writing of SQL code. And there's specific ways that we have to do things in the same way that with Python, maybe the way that we write an if statement is different than how JavaScript writes an if statement. SQL has its own syntax. It has its own different things we have to do here. Cool. So if I well, I'm gonna come here. I'm gonna go to insert because I want to create something new, right? So here's our SQL code. Here's our command pattern and what we can do. And here's a great video that's kind of walking through how we can run these specific things. And we can say, okay, cool, I want to add different pieces. This is working with the Twitter SQL. So if we were to actually come here, and we can even download. I want to do this with MySQL Workbench. We can even just follow this, to be honest. Let's see.
Oh, well, you will have to connect it again.
Connect my, oh yeah, I see it's unconnected.
Yeah, it happened to me. That's why I knew immediately.
How did you,
So I ended up going to a database,
uh-huh.
and then let me check on I went to database.
Oh, and then
connect
ran
to
it this
database.
way.
Yeah, and connected it to database. I clicked database. No, I clicked on database, and then connected the database, and then like it refreshed it, and like all
Oh, I see.
the things like became live again.
Let's check this. Cool. So what you can also, you can just get that code, download it, and then if you just connected it, even if you had it differently, you can just go and then click. So whenever we're running SQL, we're going to come here. We're in our schemas. And what we could have done, I'm going to get rid of all these because here's all the ERDs for this. We don't really need to worry about. Don't need to worry about this. Cool. Yeah, don't need to worry about this. Great. We just need to worry about this one. So what we could do and what I just did was this was empty right here where we write our queries. I just copy and pasted that code. Remember how when I said when we forward engineer in theory, we could have just written that code ourselves. That's exactly what we just did is we just took that code and we wrote it in here. Forward engineering just sort of does that for us. It's using the GUI, the graphical user interface, but you can see that all these things happened, right? We just did a whole bunch of stuff. Once I ran this, the way you run it is you put the code here and you press this, this lightning bolt, and then it ran it. And now you see that I've got a new database called Twitter that's got some tables. It's got some favorites, follows, tweets, and users. Cool. So let's actually not go to insert. I want to go ahead and go to, I want to, let's hop out, hop in. Cool. Now let's actually just query some of this, right? So what I can do is I'm on Twitter and I want to, let's go back here. I want to select all, or I want to start being able to see the data. Now, the way that MySQL works is we have some keywords like select and from, and we'll break it down here in a second. But what this is saying is select, meaning I want to get the information. This star right here means all. So anytime you see a star, that means all of it. So get every, information, get all my users, get all my tweets, get all my tables, et cetera, et cetera. And then where are you getting all from? You're getting it from your users table. So it's your table name. So when I come here to MySQL Workbench, I could say select all from, and then here is users. Now, I do have to have a semicolon at the end. What a semicolon does is it says, okay, this is the end of my SQL code. If you don't, and you have different things, like let's say you had this, and then you had like a use, I don't know, movies, DB, it's going to get confused and say, oh, we have an error, even though this would be fine. it's saying, oh, wait, this doesn't make sense because it thinks it's all just one query, right? Now, when I separate them, it works. So we got to make sure that every single time we are running these queries, once the query itself is done, or that portion, we put a semicolon, and that allows us to say, okay, great. This is what it is. And we select, and now you see we get all of, I have this database highlighted for Twitter. I say select, meaning I want to get all from, and then my table name. So within my Twitter, I have a table name of users. So I'm saying I want to get all of the values stored in this table. And so we have that right here. And it gives us our results, which is all of these basketball players right here. I'm going to pause there. Are there any questions from that?
No, I appreciate you breaking it down.
Yeah, of course. Of course. We're going to keep building upon this. Now I can do other things. We haven't really, did we talk about relationships last week? We did, right? One to many.
Yes, we did.
Cool. So, can't remember what the. Okay. In order to comment out code, you just put two dashes, and that will comment out some code. So that way we don't have to write a bunch of queries or delete it. I want you guys to be able to see this. Now, when we talked about relationships, we have a bunch of different tables, and we have faves, tweets. Remember we talked about there's the primary key and the foreign key. Do you guys remember what those were? Anybody remember what a foreign key was?
Is that when you link them up?
Yeah, right. That's the thing that's connecting the two together. Exactly. So when I have select all from faves, and I run this, here you can see faves is actually a many-to-many because it's got two different things. It's got a user ID and a tweet ID. But all we get here is some IDs, right? Let's do tweets. That actually might make a little bit more sense for right now. Let's say tweets. Cool. So here we have my tweet is created, it has an ID. It has the tweet itself. And here's my foreign key, my user ID. So this is what tells me that this, the user with the ID of 1 tweeted these 4 things. User with ID of 2 tweeted this, 3, and so on and so forth. So here is if we have a one-to-many, my user can have many tweets. A tweet can only have one user. Then this is what this one-to-many looks like, just if we're querying our database, right? Cool. Now, and you can sort of see that here. There's a bunch of different ones, exactly like what we just saw. But if I just want, when I say all, this is me getting all columns, right? So ID, tweet, user ID, created at, updated at. If I just wanted a specific column, you can see that I can actually, instead of the star, put all of my column names that I want to grab. So if I just wanted all the actual tweets itself, I can just say tweet, select tweet from tweets. What this is going to do is this is going to go and get all just the tweet portion. So not the column ID, not user ID, not created at, not updated at, specifically the tweet column from my tweet table. So if I do this, you can see that when I query, all I get is the tweet. All I get is the tweet. Maybe I want to tweet in user ID, say comma, user ID. I'm adding a second column. So I say, cool. And I get my tweet and user ID here. Now I could write it out too and say ID, and just notice that the way you write it out is the way that it's going to be given back to you, where tweet is first, user ID, then ID. Whereas when I just said all, it said ID, tweet, user ID, right? So when we say select, we are selecting which columns do we want to grab, right? Information from what column And then what table are we getting that from? Okay, I'm gonna pause right there. Are there any questions?
Not yet.
Okay,
Sounds good.
cool. Thanks, Jeffrey. Thanks, Estrella. So you might notice that this is all tweets. It's getting me everything in my database. And I mean, it's just bringing me the columns of tweet, user ID, and ID. So it's not bringing me the created and updated app, but you notice it brings me every single one of them, right? So if I had 1,000,000, it'd bring me 1,000,000. What we can do also in SQL is say, well, maybe I don't want all of them. Maybe I just want it from a specific person. Right? Maybe I just want from a specific person. Where we can, or maybe only tweets that meet a certain criteria. And so we can use what we call conditionals in the same way that we say, if X equals 2 blank, we can do the same thing with SQL, but instead of saying if, we say where. We say where. Then we put our condition. So we say where, and then we put the whatever our criteria is. So let's say I wanted to get all of the tweets where the user ID was 1. What I can do is I can say where user underscore ID equals 1. And so we should just get these 4. I've run it. Cool. So you see that we still just get those 4. And it's just the user whose ID is 1. Now notice I can put this on separate lines. You can put it, as many lines as you want, really. If that's what helps you understand it. It's the big thing is the semicolon right here. It's going to read it as if it was all one line. Even if you put it on multiple lines, this is the stopping point, is the semicolon. I don't just have this, I have different operators where I could say where user ID is greater than 1. So it's going to give me all of the tweets that, user ID 1 didn't have. I believe I could say not equals 1. Let's try that. Yep, so same thing. So I can use a lot of the same operators that we've learned in our conditional statements within my SQL query. Let's try not. I don't think that works. Let's try it. Yeah, I'm getting an error. Yeah. We say not equals 1. And that would work just fine. Cool. Okay. Now there's a lot of stuff we could do with SQL. And a lot of it, like you can get really, really heavy into this, like select with limit and offset. You're not going to need to do that. This one you might, just, for the belt exam, you might need, it might be an advanced question where I could say, I can just keep kind of adding stuff. I'm gonna say where, I'm gonna say limit is 3. And notice it only gives me the first 3 that comes back. Say 6. It's going to give me the first 6. So maybe in an exam, if we say, hey, bring this back and bring back the 3 most, or, give me the top 3 or give me the 3 most recent, something like that. Or the first 3 or something like that, you could do a limit. And so that is going to limit how many rows SQL gives back to you. How many rows SQL gives back to you. Something I would really encourage is using and playing with this SQL Zoo. SQL Zoo is going to be a way that you can just practice your SQL queries where it asks you different things. So this example uses a where clause to show the population of France. Note the string should be in single quotes. Submit, and then it gets you the population. So select population from world where name equals France. And we can see world is my table, name, continent, area, population, GDP. What would I do if I wanted the GDP of Angola? How would I do that? Right here. What would my query look like?
You select GDP
Mm-hmm.
from world,
Mm-hmm.
where name was Angola.
Yeah, exactly. And it's going to give me the GDP of Angola. Oh, it did not query, and maybe the data is not wrong. Or maybe this is just an example. Because that is correct, and we can see that that's not the right number. So maybe this is just off of this.
Could be.
But yes, that's exactly what we would do. Cool. Yeah, this is a great tool to practice your selects where. We're going to get to some more advanced stuff like group bys and counts and joins. That's kind of too advanced for right now. I just really want us to be able to query and be able to grab some information. Be able to grab some information. Cool.
I have a question, Will.
Yeah.
On that last back on the module on the class course,
Uh-huh.
the one that says you could also combine limit and offset, and then has example. How would that be? That like what would pull from that?
Yeah, great question. So what this is doing when we say limit, this is going to get me the first three back, right? Let's say it's going to give me the first three records that match that. Offset is going to say, okay, I don't want the first two. Maybe there's for some reason I don't want the first two. I just want of the first five, I want 3 through 5. So it's giving me a total of 3, but it's not giving me the first one and the second one. It's offsetting it by 2. Let's practice that right now. So let's kind of come back. Cool. Here I've got limit 6, right? And maybe I don't want these first 2. I just want the remaining, or these ones right here, right? Maybe what I can say is offset. So I could say limit 4, offset 2. And what this is going to do is it's going to, because these are my first 2, it's going to skip these 2 because offset 2. And then it's going to give me the first 4 after that. So it should just be thanks to all who helped. I took the ALS, well done, little bro, and for my baseball clinic. I run it. Yep, thanks to all who helped. I took the ALL, well done. So it skips those first 2 and it offsets it. What it's saying we could do is if instead of writing offset, I can just do this. And it will, 2, 3. So that only gave me 2. Let's see. Oh, it's because I messed up. Notice, and this is a very confusing thing. We're getting limit
Yes.
3, limit 3, offset 2. When we combine though, we put the offset first and then the limit second. It's not very well explained. So that's why this is happening, is because we put the offset first. So it's offsetting the first 4 and giving my limit of 2. So if we switch these, where the first number is my offset number and my last number is my limit number, now we get the same thing.
Okay, thank you, because I was so confused. I was
Yeah.
like, I'm not understanding that. Okay.
Yeah, that wasn't a great explanation, but yeah. So when we combine them, the first number represents the offset. The second number represents the actual limit itself. to make a little bit more sense?
Yeah, it's a lot better because I was completely confused on that part.
Yeah, no, that makes sense. Okay. So let's go back to, I'm gonna do this. Let's go back to my users. Oops. So I can say select all from users. I query it and I get all of my users here. Now I want to insert a user into my database. So this is us creating a new value, right? Us creating a new value. So we watched this video. It's going to kind of tell you how we can do this same thing. Now, one thing to note is if we are forward engineering this, if we don't do the current timestamps, so I'm assuming that this does not have the current timestamps and then current timestamps on update current timestamps thing, you know, that default expression, then we will need, again, remember I said, if we don't do that, we need to do a little bit extra code. That's what we're going to do right now, right? So when we come here, so I have all my users. Now I want to create a new user. Now ID we don't have to do because it auto increments, right? So it's going to be handled for us, but I am going to have to put something for all of this information. So I could say, maybe not. Yeah, let's do this. We'll try it. I'm worried about this date time because I haven't gone into it and seen how it's going to do, but we'll try it and see if it works. So I'm going to say insert into. We come here, insert into your table name. So in this case, it's users. Insert into users. Then I put all of my column names that I need to give a value for. So we put all of those in parentheses. So I'm setting up. So I'm going to say first name. And it has to be the exact same. Last name. Separated by commas. Handle. Birthday. Created at. Updated at. Cool. So again, I don't have to do the ID because that's going to auto increment, but all these other ones, I have to give a value if I'm going to insert or create that into my database. And so what I then say is, okay, I've said here's the columns that I need to do. Then I say values. And I actually pass in the values that I want to have. So let's pass in. And it's in, we check here, it's in parentheses again. Perfect. So here I'm creating a new user. So what do I want for first name? Maybe we'll say Will Calhoun. Finish this off. Cool. Will Calhoun. Handle is gonna maybe say we'll say W_Calhoun. Perfect. Birthday. This is the only one I don't know how we're gonna do that because I don't know how that's set up. Let's see. Well, let's come right here. It's just a date. So let's say how to insert a date in SQL.
Yeah, month, date.
Yeah, so usually it's year, month, date. So let's try it and we can always mess with it. So we'll say, cool. We'll say created at, I can say now.
Thanks for making us feel old.
That's not my real birthday, silly gooses. Or is it? Maybe, we don't know. But here, what I can do is when I'm creating that and updating, again, because I didn't do, and I'm assuming they didn't do the default expression because it's pretty old, I would have to do this now. Now, if it was defaulted, right? If we had that default expression, we can just, we would be able to skip that. Like when we forward engineered our own, we'd be able to skip that because it's going to do it for us. But we're going to assume that they didn't have that. So we insert into users, first name, last name, handle, birthday, created at, updated at, values. We pass in the values for each. Now let's test it and see. Uh-oh, got an error. Incorrect birth value. Incorrect value 1960. Let's see. Should be that, right? Did I not do it correctly?
Do you have to write the word date on there?
I don't think so. Let's try this. Yep, okay. So I just had to wrap it into a string. Dates are weird. Honestly, dates are like the bane of most developers' existence, just so you know. Okay, so I get this insert into one rows affected. So now, if I do this and I select from all users, I should be able to see, oops, what is happening? I should be able to see. Now we've got Kobe Bryant, Vince Carter, all these legends, but we have myself, right? Where we have a created at and an updated at, a handle, a last name, and a first name. And notice that it auto increments my ID. Cool. Just to prove what that is kind of the difference, let's go to my Python movie DB. And let's, I want to create a new query. Into a new one. Cool. Great. So if I select all from movies, I should get nothing. Yep, we get null, right? But we get our title, ID, genre, director, created at, updated at. Now, if I were to do the same thing, but just to prove the created at and updated at, if I want to create, I'm going to say create a new movie. Okay. Not sure why that didn't work. I'm going to say insert into. What's my table name?
Movies.
Exactly. So I'm going to say insert into movies. Then I put my columns, right? So I'm just going to say title. I'm going to say genre. And then I'm going to say director. Now, because I have that built-in value, I don't have to put created at and updated at. So that's a different portion right there, right? There's that. Oh, it's not valid at this position. Yes, it is. So look at this query that worked. Insert into. Oh. Sorry. We don't wrap these in strings. Cool. It's our values that we do. So we say values. And then does anybody have a favorite movie?
I'm big on chick flicks, so
Put it. We'll do it.
cool. The Notebook.
The Notebook. You know,
I'm
his last name is also Calhoun, and I've never seen it.
Really? I
Yeah.
was about to say, I figured you and your wife probably seen it 1,000 times if she's into chick flicks.
No, I didn't. I did have like a funny old joke that I was like, I will only see the Notebook with my wife, and we've been together for like 7 years, and I've still never seen it. So she's an attorney, so she's more of like crime and documentary.
Suspense,
So
yeah.
yeah,
Those are
yeah,
good too.
yeah. Okay. Genre. What do we say? Love story?
Drama.
Drama. Ooh. Okay, we love the drama. And then, do you know who the director is?
Uh, no.
Okay,
Okay.
we'll say some guy or gal. Some guy slash gal. Okay. I finished this with my semicolon. Cool. It says it inserted it. And so what I can do is I comment that out. I select all from movies. And notice, because I had, and I just kind of wanted to show you this for the difference, because we had that default expression in there that said current timestamp or current timestamp on update, current timestamp, we didn't have to put, like we did here, where we had to put the now. We didn't have to do that, right? And so the same thing is going to happen when we're actually coding. We're going to say, if we set up our database to where we don't have those in our actual server, in our actual code, we're going to have to put this now portion, or, Python time.now or datetime.now, something like that. Or if we just put the default expression, we can see that we don't have to put that in there. It'll automatically do it for us. I think it's nice to allow SQL to do that for us. Just one less thing on your plate, and you don't have to forget about it. But you can see that that's how we insert into our movies, or we insert into our users. Cool.
Nice.
Cool. So I do want to show you how we can, let's say we wanted to write a tweet. Now, if we again were to say, I know we have like 7 minutes left, so this will be the last thing. So if I select all from tweets. Now it is case sensitive, so we want to make sure that we are doing what we need. Make sure I'm on the right highlighted. So whenever I'm running this, I'm on the right database. Now, cool. So we get all the tweets. That's got an ID, a tweet, a user ID, created app, updated app. Now, if I want to add a tweet to myself, my person I just created, my user ID is 6. Cool. So I could say something like insert into tweets. I put all of my column names. So let's just come here. We come here, we click on tweets, and we can see all my columns right here. So I've got tweet, user underscore ID, and then we have our created app and updated app. Perfect. My value and then maybe let's say the tweet is just hanging out in the coding sphere. Cool. The user ID is going to be 6. Right? And I could just say now, comma now. Cool. Perfect. But notice I do have to put the user ID. So my specific user ID, and I run it. Let's see, it doesn't like this. Let's try it like this. Yep, okay. So it worked. So now if I were to run here, we could see at the very end, we have this with an ID of a user ID of 6, just hanging out in the coding sphere. Its ID is 13. So the last thing I can do is say something like select all from tweets where user ID equals 6. Yeah. So now I just get Will's one. Now, there's this idea of a join that we're not going to talk about today because we're out of time, and we want to make sure we'll do update and delete on Thursday. But where I can say right now, maybe I want it to be able to say Will Calhoun, you know, and then all my tweets. We can join two tables together. And that's what this foreign key does, where we can join where the user ID matches the ID of my user, right? And so that helps me associate my tables together. And then after that, we're able to basically get a whole bunch of information, and then we can kind of display that in an appropriate way. So that is creating and reading in SQL. There's a lot more to it that you can do. Again, I'd encourage you to go on SQL Zoo. That will help with selecting and creating and all of these. Don't worry about like joins or drops or left joins right now. Just really inserting and selecting would be say where I would say you would focus. And then on Thursday, we'll talk about updating. So we'll just keep working with this where we can update specific values. And then we'll work on deleting values as well. Deleting is super easy. You just say delete from blank where, you know, delete from tweets where ID is 13, and then it deletes it. So fairly simple, but are there any questions on SQL? I guess at the moment?
Yes, well, I have a question.
Yeah, go ahead.
So pretty much I was doing the users assignment. I mean, like users practice assignment for today,
Mm-hmm.
but for some reason, I can't see my Ford engineer once I click on the database menu, but I can see the reverse engineer.
Did you there's two things, either something's wrong in your engineering, and if you got an error, then that's it. And if not, you can sort of refresh your schema, your schemas, and see if it shows up that way. And if not, then maybe I would even cancel. I would kind of kill your server, get it back on, and see if it works.
Yeah, I did refresh, but
Mhm.
just the same thing. Maybe like I don't know what you would suggest.
Yeah, well, when you Ford engineered, did you get any errors? Like Estrella was getting some errors, so it looked like it worked, but it didn't.
So for me, it's so pretty much I can't see once I click on the menu, I mean the database menu,
Mhm.
I can't see the Ford engineer.
Oh, it doesn't show that because you're on Mac. Let me look. Why don't you send me an email with some screenshots?
Yeah, that
And then I can look at that tomorrow. I'll try to figure that out for you.
yeah, I will. Well, thanks a lot.
Yeah, my pleasure. Happy to help. Any other questions on this stuff? It takes a little bit of time, but
No, not at the moment. So far, I'm glad you cleared up the other stuff for me.
yeah, of course.
So,
Okay. Well, we will be back on Thursday as well, and we'll talk about updating and deleting, and then that way we can kind of just go through updating and deleting. It's pretty quick, so it's not super crazy. So
Nice. Thanks for
awesome.
that.
awesome.
Thank you.
Thanks
Have a good
everybody.
night.
Have a wonderful night. Take care.